So let's just start thermodynamics. See, what is thermodynamics? Basically, the study of flow of heat energy or energy is called thermodynamics. That the branch of physical chemistry in which we study flow of heat energy or flow of energy that comes under thermodynamics. Most importantly, some basic terms, some important basic terms of thermodynamics. First is system. Second is surrounding. And the third one is universe. And the third one is universe. It is very easy to understand all these points. If you are going to take an example, just take this container as a system. As a system, that means the reaction or the process carried out. The container in which the reaction or the process carried out, this is called system. And just outside the system, this is surrounding. This is surrounding, and system plus surrounding both together is known as universe. So if you want to define it, what is system? The container or the part of universe, we can define it as the part of universe in which reaction or process is carried out. Reaction or process is carried out. That part is called system. And what is surrounding? We can define it as part of universe other than system. Part of universe other than system, that is called surrounding. And what is universe? We can define it by system plus surrounding. That will be equal to universe. Got it?
Yes.
Okay, just write it.
Done.
Very good. So basically, these are some basic definitions. Now going for types of system. There are three types of system The first is open system. What is open system? So basically, if you boil water without any closing the upper part, if you boil water uh, by opened upper part, that is open system, because in open system there will be exchange between system and surrounding of heat energy as well as matter in the form of vapor. Then we can write that system in which heat or energy, we can say heat or energy, and mass or matter can exchange with surrounding, that is called open system. For example, we can write it as boiling water just right. This is the first part of system, and the second system is, or we can write any physical and chemical change, any physical and chemical process carried out in open vessel. In open vessel, boiling water in open vessel, that will be more understandable. So basically, any system, if you want to, if you are boiling water in an open vessel, you know that some of the heat will exchange with the surrounding, and as well as some of the matter will exchange with surrounding. That type of system is called open system. Is that clear?
Yes.
Can I change the slide?
Yes.
Now, what is closed system? It is carried out in closed vessel. So we can write the system due to closed vessel with the surrounding, it exchange only heat or energy with surrounding, not matter or mass with surrounding. So we can write the mass in which only heat or energy is exchanged, but not mass or matter. Mass can exchange with strong. So if we are going to take an example, any physical and chemical process is carried out in closed container with diathermic wall. This is very important. The boundary of closed container should be diathermic wall. What is diathermic wall? This is a boundary. You can say this is a boundary which allow only heat to pass, but no matter, but not matter, or but no matter. So basically, closed system, the boundary of closed system is made up of diathermic wall, which allows only heat energy to pass, but not matter. Just right.
Done.
Very good. Wait a minute. The third system that is very important is called isolated system. The third system, it is basically isolated system. It is a system in which neither heat nor mass can be exchanged with surrounding. Have you studied this chapter before, Akifah?
Yes. The second half.
Second part, that means
The laws of thermodynamics.
okay. In the first part, this is type of system and all.
No.
Okay. So basically, isolated system is a system in which neither heat nor mass can be exchanged with surrounding. And here you can see any physical and chemical process in which any physical and chemical process is carried out or carried in closed vessel with adiabatic wall. With adiabatic wall. What is adiabatic wall? It is a wall. Before it was enclosed vessel, it was diathermic wall, which only allows heat to pass through it, but not matter. Adiabatic wall is a wall or a boundary which does not allow heat, even heat. That means heat as well as, which does not allow heat. If it is not allowing heat to pass through it, that means it is understandable that mass cannot be passed through it. Is that clear?
Yes.
Please write it.
Done.
Now see, write a topic. Types of thermodynamic property. Types of thermodynamic properties. The first property is extensive. What is extensive property? I'm going to define it, then I will explain it. Right with the thermodynamic properties, which is mass dependent. Mass dependent. Mass dependent property is called is called extensive property, or we can either write the property which depends upon quantity of matter, which depends upon quantity of matter contained in a system. Contained in a system is called extensive property. Is called extensive property. The property which depends upon mass or size, you can say, is called extensive property. You can also write mass dependent here. I already have written, or in the end you can write size dependent. What you can write? Size dependent. Extensive property is the property which depend upon mass or size. That property is called extensive. And intensive property is a property which is independent of mass or size. Is that clear?
Yes.
We will take example, lot of example of it.
Done.
Very good. Now, come to the point, intensive property. Intensive property is mass independent property. Please write with me. Mass independent property. Mass independent property, and we can also define it, the property which is independent of quantity of matter contained in a system is called intensive property. Then how we know that something is independent of some properties is independent of property of mass, some property is independent of mass or dependent of mass. So for this we have a note which will clearly define whether it is dependent on mass or independent on mass or size, both. If I'm saying mass, that means size is also there. The property, this is very important, the property which remains same, or you can say unchanged, on division, the system into smaller parts is called intensive. Where whenever you have a question that asked about whether the property is intensive or extensive, just think like this: divide it into 2 part, 3 part, 4 part. It will be easier to divide it into 4 part, sorry, 2 parts, and just think whether it is changed or not. Just like for an example, it is very easy example. If you are going to take, if you are going to have 10 mole in this container, are you getting my point? Am I audible to you?
Yes.
In this container, 10 moles are present all over the container, and if you are going to divide it exactly into two equal halves, or whatever the size you want to divide it in, you know that half the moles will be here and half the moles will be here, right? 5 and 5, yes or no?
Yes.
So after dividing, it is changed or unchanged, remain same or changed?
Same.
Same. In the
The
first
size will
container,
not be same.
in the first container we had 10 moles, and after dividing it we got 5 and 5 moles. Then it means the mole is changed.
Yes.
Yes, the mole is changed. That means moles are, or number of moles are, extensive property that depends upon the size or mass of the system. Are you getting my point?
Yes.
Just see, we have a container, we have a system in which 10 moles are present. We just divide it equally, so half moles will be divided. So moles is extensive property. Just think that this container is a system in which 100 ml volume is present, 100 ml of water or anything, 100 liter is present. If you are going to divide it in equal size, the volume will be divided or remain same?
Divided.
The volume will be changed. It means the volume will be changed. And after dividing, if it is changed, that means volume is intensive or extensive?
Extensive.
Extensive. Very good. So this is very important to know that the property which remains same or unchanged on division the system into a smaller parts is called intensive. We will take example of everything, intensive as well as extensive. You will have to recognize and just take it, whether it is write it in bracket, whether it is I or E. Please write it.
Done.
You are very good, very good. The first note is this, and the second note, which is very important, the second note is the ratio of two extensive properties. The ratio of two extensive property is always intensive. You just have to check it whether the both are extensive. If they are extensive, both the ratios are extensive. Just take an example. Do you know density? What is the formula of density?
Mass over volume.
Mass over volume. And I just proved that if you are going to what is volume, whether volume is intensive or extensive?
Extensive.
Extensive. And if you have a container and you have a mass 10 kg, and if you are going to divide it, mass will be divided, that means mass will be remain same after division, or it will be changed?
It will be changed.
If it will be changed, mass is a extensive or intensive.
Extensive.
So the ratio of two extensive property will be always intensive or not.
Yes.
Why it is so? Why it is so? If you have a density that is basically 100 gram per ml, or 100 gram, you can say in 100 ml. So if you are going to divide it, you know that density is directly proportional to mass and density is inversely proportional to volume. Is that clear?
Yes.
If you are going to divide it, that means you are going to reduce its volume, right?
Yes.
So if you are going to reduce its volume, that means mass will be increasing in the same quantity. That's why it will be cancelled to each other, and the density will be 1 gram per ml. What I want to say is that it has both effects, directly proportional as well as inversely proportional. So it won't change. It will be after division. You know that uh, the density of water is, you can write 1 kg per meter cube or 1 gram per centimeter cube. The density of a water in a bucket is 1 gram per ml. You can write 1 gram per ml, and the density of water in pond is also 1 gram per ml. So if you are going to divide the pond or the bucket in two parts, in equal or unequal parts, the density will remain same.
Yes.
Got it? If you have any doubt, please ask me. Third point, right? Third point. Do you have any doubt regarding this?
No.
Yes or no?
No.
Thank you. So after your paper is going to start on 17th, right?
Yes.
So we are going to end this chapter by tomorrow, because a lot of topics are deleted and we can easily do it. Any physical quantity is defined as per unit mass or per unit volume or per unit area or per unit length becomes intensive. Always remember, like density, mass per unit volume, that is intensive. One of the most important point is extensive is additive in nature. Additive in nature, it is additive. That means if you are going to see volume 5 plus 5, it will be 10 liter, but intensive is not. We have 10 liter plus 5 liter, that will be 15 liter, but intensive do not have additive property because it won't add, like we will see what is the example of intensive, then you will get it. Please write it.
Done.
We have a question. You just have to write I or E in the bracket. Identify extensive or intensive. Density, temperature, mass, volume, refractive index, molarity, molality, normality, heat capacity, pressure. Please write it. Molar heat capacity, surface tension,
Done.
done. Very good. Let me know density is.
Density is intensive.
What about temperature?
Intensive.
Why it is intensive? If you are going to have uh, this is a room where you just cooled it by AC, and after dividing it, will it have certain change?
Yes.
Yes. Just suppose if your it is summer and your AC is on 16 degrees centigrade. Before before dividing it, and after just dividing it, will there be sudden change in temperature or not?
No, it will be
No,
same.
but it will take time to slow down after some time. So basically this is intensive, temperature is intensive. Is that clear?
Yes.
Why it is intensive? Because it won't change suddenly. Like if you have a volume 100 liter and you just divided it, and you will get 50 liter and 50 liter. In temperature case, if it is cooled at 16 degrees centigrade, it will take some time to change. Is that clear?
Yes.
Now mass is basically intensive or extensive?
Extensive.
Extensive. And what about volume is extensive? What about refractive index?
What is refractive index?
Refractive index is basically it is the ratio of speed between speed of light in vacuum and speed of light in any medium. So
Intensive?
basically, refractive index is intensive. Whether just think about it. If refractive index have you studied in physics, you will study in class 12th and you have studied in class 10th as well. Refractive is speed of light in air upon speed of light in water. So whether the water is of big amount more and whether the water of is very less amount, if light travels through it, the ratio will remain same. That's why it is intensive. Is that clear?
Yes.
So you know that why it is so. Speed of light in water 3 into 10 raised to the power 8 and speed of light in air, that is 3.5 into 10 raised to the power 8 something. Okay, so whether the water is like very high, very more in quantity and it is less in quantity, the speed will be remain same, the ratio will be same. Molarity. Do you have anything to say about molarity?
It
Yes.
is extensive.
Extensive. Why? Molarity has a formula, number of moles upon volume of solution, and both are basically what? Extensive or intensive?
Extensive.
Extensive. So molarity is what? Extensive or
Intense.
intensive?
Intensive.
Intense. Very good. In the same way, molality is intensive. Why? Number of moles of solute upon mass of solvent. So the
Yes.
ratio of two extensive is always intensive. In the same way, number of gram equivalent, that is upon volume. So it is also intensive. Heat capacity. Heat capacity is very important, and this is basically extensive. Pressure is intensive. Why? Pressure is equal to force upon area, right?
Yes.
And you can write it as pressure is equal to PV is equal to nRT, or you can write it as P is equal to N by V RT. You can write it or not.
Yes.
And you can also write it this is constant, number of moles and volume. So pressure is basically intensive. Yes or no? If you are
Yes.
going to take it, R is what? Constant, T is constant, number of moles and volume. Molar heat capacity, it is also intensive. It is intensive because it is confined for 1 mole. And surface tension is intensive. Please write it.
Done.
Very good. We are going to take state function and path function. So first of all, I'm going to take a state function and define it. What is a state function? So a physical and sorry, a physical quantity is said to be a state function if it is, or if it depends upon initial and final state, but not on the paths, but not on paths followed by system or covered by system, followed by system. So basically, a state function is one which depends upon initial and final position, not on the path followed by it. So if we have a graph between pressure versus volume, and if we have three path like this and like this and like this, the same destination and the same origin. This is basically A, B, and we have three paths. The first one, we have three paths. First, and here the second, and here it is the third path. So if you are going through path one, if you are going through path one, and if you are going to take this delta P, that means change in pressure. If you are going to take delta P, it will be final minus initial, yes or no?
Yes.
Path 2, if you are going to take path 2, delta P will be equal to PB minus PA in the same way as the path 1.
Yes.
And if you are going to take path 3, delta P is also equals to PB minus PA. Yes. So basically, you saw that delta P is independent of path. Delta P is independent of path. So P is a state function. P is a state function. If change in something, change in any function is independent of path, that function will be a state function. That function will be a state function. Are you getting my point?
Yes.
Please write it.
Done.
Very good. Now again I am going to write whatever I told you, that if f is a state function, so write a note with me. If f is a state function, then delta f should be path independent. I just wrote the reverse version of this. Delta P is independent of path, that means P is a state function, or if P is a state function, that means delta P is independent of path. Got it?
Yes.
Very good. What is the example of it? Pressure, temperature, volume, entropy, and this enthalpy, and this internal energy gives free energy. It's all are a state function. Do you know what P is stand for? Pressure. T stand for temperature. V stand for volume. S stand for entropy. H stand for enthalpy, and U stand for internal energy. G stand for Gibbs energy.
Done.
Done. Very good. We are going to take path function. What is path function? A function which depends upon initial and final as well as on its path. That function is called path function. So we can write easily a physical quantity is said to be path function, is said to be path function if it depends upon initial and final state as well as final state as well as path followed by system. So it has two important examples, that is basically heat and work done. Work done are path function. But heat plus work is a state function. We will come to know about it, why this is a state function. Individually, heat and work are path function, but when we sum heat and work, it will give a state function that is known as internal energy. So it is very important to note that. Please write it, then we will move to the next.
Done.
Very good. Types of thermodynamic process. Types of thermodynamic process. The first process is basically isothermal. Do you know what does it means, isothermal process? Iso means same, thermal means heat. That means a process in which temperature is constant throughout process. Temperature is constant throughout process. This type of process is called isothermal process. That means T is basically constant. T is constant. That means dt equals to 0 and delta T we can also write as equals to 0, because dt is small change, delta T big change, that will be equal to 0 delta T. That means T initial, T final minus T initial. And we know that, are you agree with this?
Yes.
Now P inversely proportional to V, which law is this? Which gas law? Pressure inversely proportional to volume.
Charles law.
Charles law. V directly proportional to T. It is Boyle's law, right?
Yes.
At constant temperature and number of moles are constant here, and we got a graph P versus V as this. And we know that here in thermodynamics, the direction of graph is very important. If the direction is like this, in the downward direction, that represents, if the direction is downward, if the direction is downward, so just see the graph. It is from Boyle's law, in which the temperature is constant. So basically it is isothermal process because temperature is constant, and basically this graph is isothermal, and you can see the graph is going downward. That means basically volume increasing, isothermal expansion. We can write expand because volume is expanding. And in the same way, we will have two graph of each, expansion, either expansion or compression, or heating or cooling. So if we have a graph P versus V like this, so reverse of this graph will be like this, and the graph will name as isothermal compression because volume is decreasing. Are you getting my point?
Yes.
So please write this too.
Done.
Done. If I'm going to give you graph and I will tell you that I will ask that please plot the graph. It was the first part. Every graph will have two graph. So if I'm going to ask you plot a graph between V versus T for isothermal, can you plot two graph of this one and another one for compression as well as expansion? So basically what we need to do, isothermal, that means temperature is constant, so temperature will be constant in this way. Are you getting my point?
Yes.
So it will be like this and the graph will be like this. And for second graph, the graph will be like this in upward direction. Now you can see basically temperature is constant, so it is isothermal, and volume is decreasing, that means compression. And here V versus T, temperature is constant, that means isothermal, and volume is increasing, that means expansion. Please write.
Done.
Now we have another process, that is isochoric. Isochoric, do you know what is isochoric process?
No.
The process in which volume is constant. The process in which volume is constant. So basically the process in which volume is constant is called, wait a minute please. Just see, isochoric process is a process in which volume is constant, that means dV equals to 0 as well as delta V is also equals to 0, right?
Yes.
Now see, P directly proportional to T, which gas law is this? Can you tell me? Gay-Lussac's law. Why I took this only? Because in this law, volume is constant. In this law, volume and number of moles are constant and we need volume. That's why I just took it, volume is constant, and this law. Why I took Boyle's law in the previous question? Because at that, in that, temperature is constant. So in the same way, we will have some graph. Now see, P, T, right? And the graph will be either this, P versus T, and the graph will be either this, right? Now,
Yes.
since volume is constant or not for both?
Yes.
Now, will there be any expansion or compression if the volume is constant?
No.
If volume is constant, that means it will not change, whether it will not increase or decrease. So in this type of situation, we deal with heating or cooling. We call it heating or cooling. So you can see basically this volume is constant, that means this is isochoric, and you can see the temperature is increasing, that's why this is Isochoric heating, and this is isochoric cooling. Got it?
Yes.
Please write it.
Done.
Very good. We will have some more graph on this. Do you know this is volume, this is T, temperature is constant, so it will be like this. Please name the graph, whether it will be heating, cooling. Can you name it?
First one is heating, second one is cooling.
You can recognize it by watching the graph, right?
Yes.
This is also isochoric because volume is constant. What about this pressure? Heating or cooling?
Heating,
Why?
because pressure is directly proportional to temperature.
Temperature, very good. And this is basically isochoric
Cooling.
cooling. Very good, very good. Please let me know if you are done with this.
Done.
Isobaric process. Isobaric process is a process in which P is constant throughout the process. So basically dP equals to 0 and delta P is also equals to 0. And you know that V is directly proportional to T. This is Charles' law at which pressure and number of moles are constant. So we are going to plot this graph. V versus T. V versus T in which pressure is constant and the graph will be like this. Please name it. One of the graph will be like this and one of the graph will be like this, right?
Yes.
So since pressure is constant, so isobaric and the volume is increasing, that's why expansion. And this is isobaric compression. Are you done with this?
Yes.
Very good. Another graph. If I will give you this, please plot the graph on your own and name it. You know that every graph will have to. Pressure is constant, so it will be like this and it will be like this. One of the graph will be like this and one of the graph will be like this. Pressure is constant, that means isobaric, and volume is increasing expansion. Pressure is like this, isobaric, and volume is decreasing, that means compression. Yes or no?
Yes.
Now see, pressure is constant, temperature is decreasing. So isobaric expansion, or you can see isobaric expansion, because volume directly proportional to temperature, and temperature decreases, that means isobaric compression. Yes or no?
Yes.
So please write it. Then we are going to have two more different process, that is adiabatic process and then cyclic process. Then we will have reversible process and irreversible process, which is very important for our derivation of work done formula.
Done.
Very good. Now the fourth one is adiabatic process. What is adiabatic process? So just write with me. The process in which there is no exchange of heat between system and surrounding is called adiabatic process. Is called adiabatic process. Adiabatic process in which heat is zero. That's why dq is, or delta q is also zero.
Done.
Wait, are you done with this?
Yes.
Very good. So basically this is adiabatic process. Now we will have another cyclic process, another process which is called cyclic process. The process in which initial and final state are same but proceeds through a series of steps is called cyclic process. It is very easy. The initial and final state are same. That means if a process is going to start, it will come to the same point. As for example, if we have a graph given P versus V, and we started from here A, then we'll go to B, then we'll come to C, and then again to D, and then to A. This type of process is called cyclic process. Is that clear?
Yes.
Please write it. all, and also write delta H, that means change in enthalpy, delta T, delta G, delta U, all have zero value in cyclic process. In cyclic process, the main thing is that every state function, change in a state function in cyclic process is zero. Okay, so I'm going to write a point for here, no, for this. If f is a state function, then delta f should be zero in cyclic process. And I have already told you that this h, t, g, u, v, all are a state function. That's why this will be zero. And delta s. Please write.
Done.
Very good. Right topic, a reversible process. Reversible process. See, reversible process is very easy to understand. I'm going to define it first. It is the pressure in which changes occurs very slowly. Changes occurs very slowly is called a reversible process. Is called a reversible process. In this process, equilibrium exists at every stage between initial and final. At every stage between initial and final. Just see, what I want to say is that I'm going to make a diagram of this. There is a piston. Mhm. There is a container in which piston is present. Here is the piston. Okay. Now see, if you are going, here is some particles of sand, a large number of particles of sand. Akifah, our class is only for 1.5 an hour or 2 hours.
I don't know.
Okay, okay. Because all the students from other batches are joining. Okay, just see what is reversible process. These are all are basically a large number of sand particles, and you are going to put one of the particles on this. There will be atmospheric pressure. Will piston move to downward direction or not? If you are going to pick one of the sand particles and put it here, Akifah, just write it. We will continue in the next class because other students are joining. Okay.